Experts, and I'd like to invite them one by one on stage. Maybe we start with Maria Eugenia Ramirez. She's the Director of Sustainability and Decarbonization at Amazon. Please give her a warm applause and welcoming her on stage. Maria. Dr. Stefan Kaufmann, he is a former Innovation Commissioner for Green Hydrogen at the Federal Ministry of Education and Research in the Federal Republic of Germany. Here's Stefan. We welcome Michael Alexander Meister. He's the COO of H-Tec Systems. Michael, welcome. And last but not least, Dr. Christoph Noeres, Head of Green Hydrogen at thyssenkrupp nucera. Christoph, welcome to stage. As I said, we start with little impulse presentations, and Stefan has the pleasure to start up front here. He already has the presenter. Stefan, we're looking forward to a little presentation. You may stand up if you like.
Yes, good afternoon to all of you. First, I want to say we already heard a lot of private R&D initiatives today from a lot of companies, also with their booths here. So my role today is a little bit the role of the former Hydrogen Commissioner of the federal government. And when we talk about scaling up of hydrogen economy and energy transition, it needs political support and it needs public funding of innovation and new technologies. And a lot of open questions are still there about the production of hydrogen, about the transport of hydrogen, also about the usage of hydrogen in small and large scale. And we have a nice overview over all these research topics, by the way, in the European strategic research and innovation agenda for hydrogen. So it's a highly recommended lecture. Yes, the central points of this research agenda are already addressed in the German hydrogen policy, especially in the 700 million funding for lead projects of the research ministry, launched already in 2020. The first big topic was production capacities and production technologies. So the first big topic in this lead project is to scaling up the electrolyzer capacity, the efficiency of electrolyzers, automation of production, also the reduction of critical raw materials in a project with a 500 million funding, H2GiGa. It's a pre-competitive cooperation of a lot of actors, also nucera and other companies, with the idea to find the best solutions, also with startups, also with mid-size, small and mid-size companies, and also with research organizations. The second point in this topic is the offshore production of hydrogen. So with a lead project, H2Mare, a 100 million research project, the idea is to produce the hydrogen offshore and to transport the molecules instead of the electrons to the shore. So much cheaper, and there are a lot of companies involved, like Siemens Gamesa, for example. And a third topic also for the production of hydrogen is, we have heard about it, turquoise hydrogen, the methane pyrolysis, also a big project we do with BASF, and we heard already that will take until 2030. The second big topic in this lead project was the infrastructure, how to transport hydrogen by ship, by pipelines, as ammonia, as liquid hydrogen, as LOHC, a lot of open questions. The usage of existing pipelines, how do we do that, how can we do that? And very important, not very new, but very important question, how to crack ammonia, how to crack the hydrogen out of the ammonia, and how to use ammonia as ammonia in the hydrogen economy. So therefore, we have a lead project with TransHyDE, also funded with 100 million euros. So all of these projects, really pre-competitive cooperation, a lot of research inside, but it's really applied science. It's not fundamental science anymore. And then we have also projects of the economy ministry, right, the Reallabore, and also the big centers for fuel cell technologies of the Ministry of Transport. And if you look at the European level, These are a little bit, for example, the ammonia project to see what are all the research questions. If you look at the European level, very interesting is the, and most relevant as a funding instrument is the EU Innovation Fund. It's an open call for TRL 7 to 9. It started 2020. Now, in the newest call with a 3 billion funding, started in autumn last year. And it's about clean tech manufacturing, CO2 reduction, not only hydrogen, but also other technologies. For example, capturing of non-avoidable CO2 emissions in the cement industry. That is very interesting. The degree of innovation is of relevance, emissions efficiency, project maturity, scalability, and the cost efficiency as criteria for these fundings. So just to give a little framework what happened, for sure we have a lot of R&D in the private sector, and we need it. But we also need this public funding. We need a political support for all these topics, and there are a lot of open questions, as I said, and the role of politics is to give the right support for the scaling up of the hydrogen economy.
Great, thank you, Stefan. And now, Michael continues and gives us an insight into innovations by
Yeah, thanks a lot. So I've heard we're actually the last item on the agenda before there's food, drinks, and networking. So I've been told to be quick to stay on time, that we go to the fun or even more fun part of this event. So we'll give our very best, I guess, in the following. So I'm a CEO of H-Tec. Can we see the presentation? Good, thanks. So we're in the business of producing, developing, and selling PEM electrolyzers, as most of you know, I guess. We have 25 years of experience in doing so, and just recently been acquired by MAN, and thus we're also part of the Volkswagen Group. And right now we're in the phase of bringing everything together, the resources, the know-how, the talent, and we're united by one big vision, and that is to avoid 1% of greenhouse gases globally with our products and services. And we've come a long way, you've seen that, and that's also true not only for history and funding and ownership, but also for our products. So right now, our main product is a 1 megawatt containerized PEM electrolyzer, but we've just recently, I think in April, announced our new member to the product family, which is the MHP system, the modular hydrogen platform, and we'll produce that in 10 megawatt skids rather as an indoor solution. And at a short period of time, we've seen a lot of pull and demand out of the market. Coming more to the production side of things, we're having two sites in Germany, and one is clearly focused on the stack production development and also the purchasing of the components of the stack, and that is in Hamburg. In Hamburg, we've just recently announced and had the great groundbreaking for our new gigawatt factory that will have nearly 12,000 square meters of production space and another 6,000 for office testing and so on and so forth, and we'll have the factor 10 then to our current footprint and capacities. And in the south, we're focusing on the electrolyzer and the BOP with 7,000 square meters of production capacity, and then we are feasible to produce in the gigawatt scale. There we've come also a long way. I think in 18 months, we've had the factor of 20 of our former footprint to the one we're seeing right now. So we're on the fast track to ramp up our serious production. And that's a bit what we are focusing on right now, but I think the theme of this item on the agenda today is, on the one hand, innovations, on the other hand, scaling up production. And when I think of scaling up the production, what does it mean to me, and how do I think about it? It's scaling up, obviously, your own production facilities. That what I was talking about right now. So you think about structures, you think about talent, processes, and so on and so forth. And what is actually the task at hand, and the other side of the equation, at least in my perspective, is scaling up the ecosystem, scaling up the supply chain, ramping up our partners. And I won't read out all of the bullet points you can see here on the right-hand side, but I guess you share my perspective that is a task for the entire hydrogen community, so basically for all of us in that room. And at least we will invest heavily in the next couple of months and years in our partnerships and suppliers. And the other aspect of today is innovation, and I may have a bit of a controversial perspective when it comes to innovations, because there's a lot of buzz out there when you talk to production experts and enthusiasts. Let's take the first one here, predictive maintenance. So we as H-Tec had a bit of a different approach. We invested deliberately in redundant stacking equipment, for example, because I'm coming from the automotive industry, from BMW, and if you have a new equipment with new people in a new facility with a new product and a new process, you don't want to have that. And what we do is deliberately have redundant equipment to be able to deliver to our customers on time and on quality. And I don't want to go through all of those, but another example is certainly automation. So we also wanted to automate huge chunks of our processes when it comes to the Gigafactory. And we made the analysis and pretty much saw that there's parts of our processes in production that certainly can be automated, and we will do that, and they are much more efficient at doing that. But there are other parts where that doesn't make any sense from an efficiency perspective, but also when it comes to this idea of robustness. So my 2 cents when it comes to innovations, basically, that we need to get the basics right in the next couple of months and years. That's the main aspect, that we shouldn't, as an industry, overpromise, that we should walk the talk, invest in robust processes, and build that way trust in the industry. Thanks.
Thank you very much, Michael. A couple of topics to discuss later, I think. And Christoph's already getting up. That's great, because he'll be the next. And with his presentation, moving hydrogen towards a high-volume product business with technology standardized.
Yeah. A very good afternoon to everybody here. My name is Christoph Noeres. I'm heading the green hydrogen business at thyssenkrupp nucera. Maybe just a quick summary towards what is thyssenkrupp nucera. I think some people already know it. So we are not a real startup. We are a company with close to 100 years heritage, real industrial DNA, because we are a technology division of the former thyssenkrupp Uhde, the plant engineering business inside thyssenkrupp. And so we have built electrolyzer plants for the chemical industry for the last 50 years, more than 600 plants around the world, for all the famous customers who know how to do chemicals like BASF, like Bayer, Covestro, Oxychem, all the big shots in the chemical industry. And we have decided, as said, we are coming from a business, chlor-alkali business, and we have decided roughly 10 years ago, looking into the market and say, yes, hydrogen business is something very interesting, and have done already very early stage significant steps. And one important step, one important question was, how will this market develop? And I just recognize, if you go to the next slide, you will see that beginning of 2020, just at the beginning of the COVID phase, we had a big strategy question, where we want to go, what is the real picture of the future market? And it was for us inside thyssenkrupp very important, because we had to decide how we want to grow in that kind of company. How can we, in a fast way, grow? And so we had to understand, is the market a market of single megawatt projects, remote, for example, for mobility solutions, or is it a market which will serve the industry, which is for multi-hundred megawatt plants, for gigawatt plants? And our analysis was quite clear, and based on that analysis, we prepared this painting here, and we said it's clear the renewable energy market has changed significantly over the last 10 years, and there will be a huge amount of renewable energy available. And to make a real impact on CO2 footprint, I think for sure mobility is a very important thing, but you need quantities. You need quantities to drive down the cost. That is a typical way how you come down with cost in the production industry, in the chemical industry, by scale. And so we said it's clear, if you go to the end markets, to the off-takers, in the first phase, this will be not driven by fuel cell cars. No, it will be driven by the real business cases in the first phase. And these are the 3 business cases. This one is for refineries to exchange gray hydrogen towards green hydrogen. It is fertilizer, driving fertilizers towards green ammonia. And it's also regarding steel. We as thyssenkrupp are very much looking for that one as well, to have green steel, because steel is one of the big CO2 emitters around the world. And so it was clear it will be in the first phase an industrial market, and we need these large-scale applications. And we need to come up with a product which is large-scale, which is serving 100 megawatt, even gigawatt plants. And that was already a decision we made very beginning of 2020. And as you might have seen in the press, we have already a track record of more than 3 gigawatt of signed contracts, not MOUs, not NDAs, real supply contracts, more than 3 gigawatts. And this is projects like NEOM, like Shell in Rotterdam, and just 2 weeks ago we signed a contract and it was published with H2 Green Steel in Sweden. I think just that is a clear track record and showing that we're on the right way. So how do we do that? And we have the chance that we can go backwards to the existing technology we utilize for chloralkali technology. So we have a supply chain, a design of an electrolyzer, which we can utilize even for alkaline water electrolysis. And how to come to real big scale. And in electrolysis, that is the number one way to do it, is it by, for sure, to have an electrolytic single element, which has already a big scale. So our element is around 3 square meters size. And then to number up. And numbering up is a very important method, because with numbering up, you reduce significantly the risk if you scale up or if you ramp up capacity. That we are doing, so we have one single element on the left side, then we sum up that to a single module, which is around 20 megawatts with around 300 single elements, and then you can take that kind of 20 megawatt module and design whatever size of plant you need. And that is the way how we come down with overall cost. And in addition to that, for sure, you have to scale up the whole supply chain. If you look on the supply chain, these are more than 100 single subcontractors, even subcontractors. And you have to give them the clear way forward, and that is the only way with standardization. And if you know the chemical industry or the process industry, there are a lot of customers with a lot of heritage, a lot of customer standards, refinery standards. That is all not good for a standard product. So you need a vendor, expert, technology supplier standard, and with that you can really standardize the whole supply chain and come to scale. That's our way forward with alkaline water electrolysis technology, and we have a clear path forward that we can further optimize the technology in the future, in the next 10 years. We are used to that because also in the chloralkali industry, getting capex down, improving the efficiency was a clear target, because companies in the chemical industry have also to cut down operating costs, and it's each single percentage in the efficiency is of the essence, and you have to fight for that. So we are very much used for that and fighting forward to improve capex and opex. Thank you very much.
Thank you, Christoph. So, standardization, the major point we have heard here, and now we come to Maria, and she talks about Emerson and how, yes, digital twins and integrated technologies can help to improve efficiency and bring down costs and TCOs for hydrogen solutions.
Don't say more, because you are just...
That was half the presentation.
Yes. Okay. Yes, thank you a lot to invite me. Very happy to be here with this big expertise on the table. I am Sustainability and Decarbonization Sales Director for Emerson Europe, but a little more first about what is Emerson. Emerson is a global automation company serving and helping customers in the most critical industries, chemical, oil and gas, life science, with 2 business segments, clear differentiate. That is the software and control. We acquired part of AspenTech as software, our main software, in 2022. And then also the part of intelligent device that is coming from measurement analytical, valves, productivity and safety, and all kind of products. So we are an American company with our headquarters in St. Louis, and we trade in the New York stock market. But we have more than 130 manufacturing locations around the world. Coming a little bit about our sustainability business, last year the 70% of our sales was from technology enabling sustainability. The 65% of the electric vehicles in 2022 were made with Emerson solutions, and another date is more than 6,000 wind turbines are controlled with Emerson system. So sustainability is very important for Emerson. We group our effort in 3 main pillars, very fast on those. Just is greening off, greening by, and greening with. The greening off is that is important also for all our customers, because all activities that Emerson is taking to improve our impact and our greenhouse emissions in our production facilities and in our offices. With that, we are helping to reduce the carbon footprint of our products. The greening with is because, as we have spoken today or during all the sessions, is that the greening with is the environmental and sustainability and low carbon transition is quite complex, including many uncertainties, such that not one single stakeholders can tackle it alone. So for us, the greening with is all the multi-alliances that we are doing with different academies, associations, other businesses to face the challenge of environmental and sustainability solutions. And the greening by, that is the most important because it's the one that have greatest impact in the net zero carbon target, because it's all the solutions and technology that are growing in the last time that Emerson is developing and expertise to help to our customers in their sustainability journey. Okay, so coming to hydrogen, it's a very busy slide, but you can see here that we have products and we are providing solutions in all the value chains of hydrogen, from electrolyzer manufacturing to refueling stations to fuel cell, even that we are providing kits for hydrogen injection with blended natural gas. So our main product here is instruments, intelligent instruments that can be connected to the gateway, the H-gateway, to the cloud, and just collect all the data from the field and take smart decisions and improve operations. But focusing a little more about, and you already commented about digital twin, when we spoke to reduce the cost of the main part, because we spoke today, the main cost is in the electricity, so in the electrolysis process. So it's very important the optimization of the cost in this process, because we'll have a domino effect in all the value in the hydrogen value chains. So for that, the digital twin here is a really game changer. Because with the digital twin, we, as you know, is an engineering tool that we have virtual data from historic and also from different machine learning AIT technologies. So we have enough virtual data, dynamic, to mainly do 2 things. One is validate the design of our electrolyzer. This validation includes to play with the different scenarios and the what-if analysis that we can do with the different equipments and different measurements elements that we are having virtual. And the second one is also to use as design, as decision tool for the operation. Okay, with the first one, we can improve the efficiency if we work for instance, if we get less impurities in the water purification system or in the hydrogen purification system, or if we work in the rectification system and minimize the ratio voltage current with the ripple. So this means that with digital twin, we are extending the lifetime of our products because we are able to do preventive maintenance, and we are reducing and increasing the efficiency of the electrolyzer, so reducing finally the cost. But, we spoke today about, and these 2 curves are, I think, for all of you well known, that these are the larger plants, reduce cost. So Maybe when we spoke about 4 megawatts electrolyzer, the digital twin, that even that can increase efficiency and increase the lifetime of the products, make no sense because it's just one single product, so we can prepare just a missile and do it, the calculation. But what about a megawatts plant? If we use digital twin in a 20 megawatts plan, will help us a lot for future decisions in the 100 and 200, because at the end, we are not all of us thinking in the 20 megawatts, but in the 100 and 200 megawatts. But additional thing is that in 2021, we worked with a Liquid for Vancouver project in Canada, in Quebec. And after it was the biggest one in that moment, that was 20 megawatts plan. And after the feedback that working with them is that the most important is the proper safety plan implemented during the project. This means that the automation is when we start speaking about biggest, the automation part is definitely very important. So the safety coming with the control system became relevant, and this cannot be delegated in the OEM electrolyzer. And what if there are several stacks, multi-stacks putting together to get the 100 to 200 megawatts? So that is not just the control system of the safety control system, it's just also all the AspenTech tools, for instance, software tools, or our data lake, that to unify all the data in one single platform, to have there the different disciplines as the electricity coming from the renewable, or the electrolyzer, or the balance of plant. And here also became very important the digital twin, really important to validate the design of, for instance, the control philosophy, to also run different simulations to see to predict the perform of the overall process, and also, as we comment, to prevent and to do predictive maintenance and avoid costly shutdowns. And the last part is why not to do for the hydrogen real businesses and have a fleet with different hydrogen plants in the same country and be managed by a single control room, and play with that as is done with the electrical from wind and solar plant. For that reason, also for that part, also the technology is really important, because with software and our OCI solutions, we can control and monitor the total system. Okay, just some examples of how we've been working with big plants and how the software and the digitalization became important. Thank you very much.
Thank you, Maria. Thank you, everybody. Let's get a bit into discussion. I would like to have at least 3 topics being covered, maybe in 3 rounds at least, also depending on what further questions come from the audience. Maybe the first one to focus on: what kind of innovation do you think is important for the ramp-up of hydrogen project? Second one is a bit the question what politics can do also to support innovation, and third, what are good locations for innovation nationally, internationally. So starting with the first one, maybe with you, Stefan, what would you say from your perspective, not only looking at Germany, but you have obviously also an international view, what would you think are the most urgent, most pressing innovations needed or desired for ramping up hydrogen production facilities?
Yeah, not that easy to answer. So we see a lot of necessary innovation on the application side, and we heard a lot here, and we see the ramp of the production of electrolyzers is very important. What I said, I think more of infrastructures and thinking more of these. What can politics do in this ramping up of hydrogen economy? And that is, I think we did a lot of innovation funding on the application side and also on crucial first questions, but now I think the role of politics is to finance infrastructure and to look for the pipeline system, for example, to look also for international corporations, to look for the supply side of hydrogen to Europe and to Germany. And all these innovation questions are, I think, better to be answered by the companies dealing with electrolyzer capacities.
Okay, then let's go. Michael.
I mean, there's many. I guess iridium loading is still a big thing. Degradation, availability. So there are so many topics we still have to cross. But if I look at our business, it's still on a broader scale. It's loading and it's degradation.
Okay, and Christoph?
I would say if you look on the ramp up, I see two items. The first item at this moment is we have to get the whole supply chains ready. And if you look on our projects and say we are used to big industrial projects. We have done always big projects in the past, but these are really big. If you look on NEOM, I just had the chance to visit NEOM beginning of this year. And if you see the overall construction activities at the coast side, which is not only the octagon, the line, but also around the octagon, the big facility which is under construction by Air Products, including the solar and wind fields, the electrolysis, the ammonia plant, the jetties. It's just huge. It's 2 point something, what we say more than 2 gigawatts. And we have to get the supply chain for this ready. We have in total more than 3 gigawatts under contract. So that is, to a certain extent, you can call it innovation, but you need just to get all the whole supply chain with all the different small entities, players in the market, ready to invest into their workshops. Because we are coming, telling them, we want to buy this not 2 or 10 times. No, we want to buy it 10,000, 30,000 times. Yeah? Mm-hmm. And they have to install new workshops for that. So we have to give the confidence, the trust into all these mostly smaller companies, not only in Europe, around the world, also in Asia, to get the whole supply chain running. Regarding innovation, so that's the next step for us for the future, because we are quite sure that alkaline water electrolysis, where we are, is for a certain part of the market, and it's one of the bigger parts of the market. It's just the right application. And as you said, there are fields for sure, like precious metals loading. We have to work further on that. We are working on that since I'm in the company for more than 20 years. We are always working on coating improvements. That means reducing precious metals, getting the cost down at the same time, also voltage down of electrolysis cell, improving diaphragms, improving the overall design, the hydraulics, and that's a continuous process, and it takes time because. All the design, the testing, you don't do that in 1 or 2 years. If you want to have this 200 whatever gigawatt installed or demand in 2030, you have to take that what is now available and start the projects. Otherwise, you have nothing in 2030. So those innovations are for the time afterwards, because the plant will run for 20, 30 years, and we have to provide to them services, improvements continuously so that they can improve their costs and their OPEX.
Yeah. So classically, I mean, with product innovation, but also processes, but they also understand, let's say, collaboration innovation, so to speak, to bring everybody to the table and make it all happen together.
Correct.
And can digitalization, from your point of view, help there? I mean, maybe both of you? And then, of course, I come to you, Mario.
I think for sure it's in the process industry, that is something as best practice. It's something very important to have a good understanding of the data, to analyze properly data, because you receive with electrolysis a lot of data. You have dynamic data starting up, shutting down, and then it's not one reactor, like for an ammonia plant. No, you have 20,000 small reactors. And this is a hell of number of data, and you have to somehow to work on that one and to get that properly analyzed with a digital twin, for example, and improve the processing accordingly.
All right. Michael, your view of digitalization in that innovation sphere?
Yeah, I think so too. So I basically agree. I think as I said also in my presentation, the supply chain is the biggest part of the equation right now. What certainly helps, what we are investing in, is to get your supply chain transparent until basically tier X. So, because what's happening is that you manage your tier ones and you get basically everything up and running, and then something, some process defaults in the process, and then you have nothing. And basically, we want to increase massively the transparency, like who is actually really supplying us from where, on which routes, which capacities, to then be able to react. Yeah? And there, digitalization certainly helps.
Stefan, do you fund or have particular projects in mind for digitalization? Digitalization projects that you have in mind?
It's also funded by the ministries, but I see a lot of companies now emerging and dealing with digital twins, and I think it's a big business, and it's for sure necessary then to improve the electrolyzer, to run the electrolyzers.
Yeah, Maria, as you talked about the digital twin, what
Yes.
role can that play further than maybe just for simulating the immediate production facility, so in terms of a whole life cycle of projects also?
Yes, yes, indeed. Yes, regarding innovation, I think that all the innovation and technology should be go to accelerate the learning rate. That is very important, and to help to reduce the risk during project execution and during operation. So, digital twin, in the operation life cycle of the plant have a big important role, because I already commented, right, that all the data, all the inputs will help the plant managers to avoid unscheduled and shutdowns, and are really costly, and also will help to increase the production. If you run the process and see the bottlenecking, for instance, you can just do more efficient production, or you can do very safe operator training, safe in offline and no risk environment. So, and the good thing about the digital twin is when it's already operating, it's becoming more and more accuracy, because it's taking data from the own process. So it's the accuracy and the certainty is became bigger. So I think that digital twin will be one of the most important things for the hydrogen, specifically for the accelerate the learning rate. Yeah.
Okay, thank you. Actually, the audience is very much interested in if you, in your companies, account for your own emissions as a company. I think, Maria, you talked a bit about it. How about nucera, H-Tec? You talked about the transparency of the supply chain, I think, and that goes into that direction, right?
Yeah, to be very transparent about that one, we were starting that now. So that's basically one of the pillars we're ramping up and focusing. But we at the moment, it would be a lie to say that we had complete transparency about our footprint. When we now go at bigger scales in the Gigafactory, we're right from the beginning designing basically the entire factory completely carbon neutral. We have solar on the roof, a green roof. We have PPAs that are in place and that will help us to basically get the energy from obviously renewable resources. And so they are basically right from the start, we plan it completely carbon neutral for the existing footprint in Augsburg and our supplier landscape, which is in the process of getting started.
Christoph?
I would say a very similar question, because there's a lot of existing supply chain there, and you have to transform that. So there are clear targets in place. I think a clear focus for the coming 1 to 3 years to improve that significantly. But we are all looking into new to further scale up and to have new setups for production. And if you go a new production site, it's a no-brainer. You will have it net zero and properly set up there.
Another question that many people in the audience are interested in is this one. Why does the sale of waste oxygen to improve the hydrogen production business case, why is that never mentioned, or maybe not enough? Is this happening in practice? Who would like to take it, Michael?
Yeah, it's not the standard at the moment for us, but we're seeing it the first projects. So where there are specific use cases to use the oxygen, we use it and sell it. But the standard is still to blow it in the atmosphere. But that is also something that is ramping up right now, but still not the standard.
I would say I agree to that one. It's an additional value stream. I think it can improve the business case. But to have a good business case, the base case must fit. Yeah? You cannot sanitize or improve significantly with the oxygen data. And if you have cases like existing assets, if you install the electrolysis facility, for example, in existing integrated sites, yeah, industrial sites, for sure there's always a good chance to tie into existing oxygen networks. There will be downstream units who have already certain use cases for oxygen, and that will be one of the very nice cases. Yeah. Oxyfuel is for sure a future use case, but I can say the current, most of the current projects looking into that one, but they have to fly without that one.
Maria, would you like to comment on this? Would you like to comment on this question of the waste oxygen?
Yes, I think that I agree with them that I hear that is additional business, and I am sure that is always we are looking for the way to continue looking for improve the business case there because it's the need of all of us.
Yeah. Okay, good. Let's turn to the second topic, which I mentioned as a third one. Let's do it now. The question of the locations, because actually there is one question, a very particular one to you, Michael. Let's say within Germany you have two locations. You presented that, Hamburg, Augsburg. What's the rationale here? Why this geographical separation?
A good one. I think the simple answer would be it's simply in the historical development. So the origin of H-Tec is clearly in the north, and the south was basically added on later. And so we had a very interesting discussion actually last year when we took the decision for the gigawatt stack factory, and there was basically a tough decision, to be quite honest, to not produce it and not construct it in Germany, but to go abroad where energy prices are more attractive for us. But there were basically two reasons for us why we are not doing this. First of all, we are convinced that Germany and Hamburg can be competitive. We want to make it a success case out of Germany, and that's a deliberate decision. And that also fits better to our shareholders and owners, and I think we have a common vision regarding that aspect. And the second one, we have a very, very strong stack team in Hamburg. That is the nucleus of our company. That's the heart and soul. And we would lose some of those talent, obviously, when we have put the factory somewhere else. And that was basically also then a proactive decision to invest in our staff, kind of, and keep the staff, make it even more powerful and expand on it. So the new stack factory will be 4 kilometers away from our current location. So it's basically no reason to, there's no reason for the workforce to do anything in that regard. And so that was quite a tough decision because the business case, to be quite honest, would be more attractive maybe somewhere else. But we deliberately took the decision not to do so.
Okay, Christoph, where interesting locations from the innovation perspective, let's say first?
Yeah, maybe from our company point of view. So first of all, we as thyssenkrupp nucera are a typical lean asset company. So we are not a classic manufacturing company, but we have partners to manufacture. So from our heritage, we have our engineering centers, our R&D centers around the world. So our headquarters in Dortmund, coming from the very old days, Friedrich Ude GmbH, working in the ammonia business 100 years ago. Yeah, and we have engineering centers in China, in Japan, in the US, and in Italy. So this has mainly a historical reason due to the former business we have done. And we are for sure we're looking now into the markets and will grow further also innovation into those regions where we see really the market growing. Regarding the manufacturing hubs, so we are sure, and I think it was proven the last 2 or 3 years. Yeah? I think everybody who has done real business the last 2 or 3 years was very thank you to his supply chain manager when his supply chain was a really resilient thing and would survive all the stress we had over the last 2 or 3 years. And so you have to grow your supply chain as per the markets you serve, and we fully agree with that one. So for sure we have a European supply chain. We've purchased a lot in Asia, and as well as North America as well. And our final assembly is no secret, but we're doing partly in Spain and partly in Southeast Asia, because it is really big industrial activity, and from workforce cost point of view, we see there is significant advantage here. innovation centers, key innovation centers, Germany and Japan.
Stefan, why is Germany an attractive location, let's say, also for innovation hydrogen, and which benchmarks also, for example, do you look at internationally?
No, at first I want to say, as somebody living in Stuttgart, I'm very happy about the geographical separation, because we really have a little bit of problem of north-south. We have all the production hubs, we have all the green electricity, we have all the harbors in the northern part of Germany, so a lot of industry and hubs will be built there, and we do have a very bad situation in the southern part. I think we have really strong research institutes in the southern part of Germany on the application side, but we have to bring also the hydrogen for the testing also to these production sites in the southern part of Germany. So I'm happy about H-Tec, but I'm a little bit fearing that we will have this north-south discussion in Germany, and also price zones and so on. So that is, from a political point of view, it's
German perspective. And internationally, where do we stand?
Internationally, I'm traveling a lot. I see at the moment for sure these countries with existing energy infrastructure and experience and workforce and existing harbor infrastructure. So talking about Middle East, talking about northern part of Europe, Scotland, Ireland, have advantages at the moment. And then for sure, regarding the IRA as a funding scheme, there's a lot of attractivity now in Northern America, also Canada included, I think, for the first big production sites.
What about China? When we talk technological innovation, we always need to look at China.
Yeah, I was in China last week, very interesting. So around 100 companies developing electrolyzers. Most of them alkalic electrolyzers, so 30 of them seems to be able to show something, but we have completely lack of transparency. What are the data? What is efficiency of all these electrolyzers? They start now to sell in Europe, like Longi, so a lot of innovation funding also from the Chinese government, but it's at the moment very difficult to see where is China. I think they are for sure not that efficient like we are at the moment, but maybe 80%, but the price is okay. It's it's very cheap compared. So we have to see the market in the next years.
Yeah, maybe I can chip in, Stefan. So we are working in China already for the last 20 years. We have a even manufacturing site there with our partner, and for chlor-alkali technology. We have a service center there and doing business in China for the last 20 years. And maybe for everybody to make it quite clear, in China, so the chlor-alkali business is producing the core key chemicals of the chemical industry, chlorine and caustic soda. And what was built up as capacity around the world, excluding China, from 1910 to 1980 or 1990, was once again built in China from 2000 to 2015, I think, roughly. Yeah? So 40 million tons around the world, excluding China. Once again in China, 40 million tons. So in China was a significant market, not as big as hydrogen, for chlor-alkali electrolysis. And we were capable to compete versus Chinese competition there. And we have 1/3 of the market share there. For sure, it's a different market, I have to say. But I think it's a complete different market than like a solar or wind turbine market. It has one more degree of complexity because it's a chemical industrial plant. And as soon as you go there with a real somebody from the chemical industry who has to fulfill safety standards, who has to operate it, his operators has to work with the equipment all day over 20 years. And he will judge whether the safety standards are the same. And if the safety standards are the same, the cost level will be very, very similar.
Yeah. Okay. Maria, what is your view, or can you say Amazon's view from the international perspective?
Yes, we have a global organization considering sustainability and decarbonization. We think that more in this, for this business is really important, the collaboration between different regions, because the innovation and the development of the fats are so fast, and we are collaborating a lot, all of us. We think that until now, Europe is like has been all the companies here has been like leading the way of the projects and the news. Now we see that yes, China is a little more accelerating in the last time is what we see, and yes, US also with the IRA also is this, but still we think that Europe is having the core of the technology, at least the most companies, more important companies. Yeah.
Mm-hmm. Did the Ukraine war redraw the H2 innovation map internationally? Anybody? Stefan?
Yeah, it speeded it up. So because we had this idea of a transition, steel industry from coal via natural gas to hydrogen, and yes, this is not anymore. So it showed very clearly that we have to speed up our innovation map and all what we are doing in hydrogen.
Everybody's nodding. Let me ask the two gentlemen, what would you expect as our third topic as political support right now to, let's say, accelerate also the ramp up of hydrogen production? Whoever would like to start, Michael.
Yeah, I think the what is actually quite good. Yeah, the how is really bad. Yeah. So if you want to understand the Inflation Reduction Act, you read through 5 to 10 pages and you've covered 80% of it, I guess, to be a bit more black and white here. If you want to understand the answer of the European Union or federal, local, national regulations and incentivation, you have to hire a consultant and they put you through a 5-month project and you spend a couple of 10,000 euros on that. This is kind of ridiculous. Yeah. So basically, I think we're well underway in the what, we're not well underway in the how we do it. We have to make it much more transparent, much simpler and faster, obviously. And it's, to be quite honest, not only about the big bucks. Yeah? So resources is not maybe the main issue for all of the players out there, but it's then pragmatic help when it comes to approvals, when it comes to BIMSCH-Genehmigungen and stuff like that. And then basically the answer always is, but this is decided on the local level. We cannot do anything there. But that's actually then the killers that kill our timelines, and that where we lose competitiveness and we lose ground to fierce competition left, right, and center.
Mm-hmm. Christoph, what's your wish? Let's say with regard to innovation, research funding or so.
I think regarding research and innovation funding, here in Europe, especially the German government is doing a great job. We had at thyssenkrupp, we had the 2016 decision to go to carbon to chem, which is a great installation at the Duisburg steel site, where we are investigating electrolysis and as downstream processes with different players together, not only thyssenkrupp players there. We received a significant funding for that, and I have to say, great.
What needs to happen now?
I think this has to a certain extent continue on the innovation side. We have, I think, especially if you look on innovation, it's not all about budgets. We need researchers. We need people. I think that is really one of the biggest bottlenecks everybody, besides the supply chain, if you talk about innovation. It's not only test facilities and test fields, which is about CapEx. It's about the right people who have the real education to do that and the willingness to do that. And that is really one of the challenges we have. And if I talk to certain other market players, I think everybody is facing one of the key issues. So I think we have to further improve the situation to get talents into the country, and we have to do everything to grow our staff coming from the universities. I just talked to one of the universities. They have issues to get professors for the different shares, and I think that shows the issue we have over the next 10 years. So we have to work on that.
Whom do you tell? Yes. And Maria, any wishes for the politicians, basically, to support innovation and research?
Yes, definitely. I mean, I think the important message here is that all of the customers need to start small, but think in big, because the scale up is the most important. So definitely that is one of the main reasons.
Okay, Stefan, you have the final word. Can you fulfill these wishes, let's say, also for human resources? Do you have a view, because you're from that
we talked about
Ministry of
innovation funding, we talked about what is good, but you're completely right. What is happening in Europe as an answer to IRA or Canadian incentives is nothing. It has to be pragmatic, it has to be faster, so we need completely different incentives. But it's not about innovation funding, it's about attracting, ramping up the hydrogen economy, and therefore, and to hold the industry in Europe. That is the task of the European Union. And in that case, I'm not satisfied. We have to work on that in the European Union together.
And work on the education part, I think. That's what we hear. So thank you very much. We could talk for much longer. It was a great discussion, but it's already over. Thank you to the four of you.